Welcome back. So now we're determining if we got a block, and if we did, we cut the damage in half. The next calculation I'd like to make is taking armor and armor penetration into account. Now, the order in which we do these calculations matters, right? Because if we cut the damage in half first, then that's going to affect how subsequent calculations are made depending on what those calculations are mathematically. So the way that I'd like to do it is to determine if there's a block first and foremost. And then from there, any additional calculations will work based on that result. If the damage has been cut in half, then the starting amount of damage going into the next calculations will be half as large. And the reason for that choice is, well, the choice had to be made, and this makes sense to me. Now, we're going to go up to aura damage statics. We're already capturing armor. We're going to capture armor penetration now. As the two of these kind of coincide together, they work with each other, or I should say they work against one another, as armor penetration ignores a percentage of the target's armor, of the victim's armor. So we're going to capture armor penetration, which means we need to use armor penetration with this macro, and for the define version of this macro, we're going to also use armor penetration, but in this case, we're going to capture armor penetration from the source, right? Because armor and block chance, those are for the defending character. The attacker is what uses the armor penetration. So we're going to compare the armor penetration of the source with the armor of the target. Now we do need to add this to relevant attributes to capture. So we'll do that as well, adding our armor penetration def to that array. And then we can scroll down and capture the values of armor and armor penetration. And these three lines here are what I'm looking at. This is how we captured our target block chance. We're going to copy those three lines and paste them just beneath here. And we're going to change this to armor, and this is going to be armor on the target. So this can be target armor. Now, target armor will be initialized to 0. But we're going to pass in to attempt calculate captured attribute magnitude, the armor def. We're also going to pass in this target armor float. And then we're going to use max on target armor, maxing itself in 0. So that way we'll never get a negative value. So that's our target's armor. We're also going to get the source armor penetration. So we're going to call this one source armor penetration, and we're capturing armor penetration def. That's the first input, and we're passing in source armor penetration, and then we'll go ahead and do the max trick with source armor penetration as well. So after damage, we can have a couple of comments here as well. And right here, this comment, if block half the damage, that's really what this line is doing here. So I'm going to move this comment down to right here. This is where we're halving the damage. Okay, so now our comments are a little bit descriptive of our intentions here. And for this next comment, we're going to say armor penetration ignores a percentage of the target's armor. So how are we going to implement this mathematically? Well, here's a way that I'd like to do it. I'm going to make a const float called effective armor. And this will be the amount of armor left over after we've ignored a percentage of it. Now, if we're going to ignore a percentage of target armor, then we're going to take target armor and multiply it by something. We're going to say times equals here and multiply by some fraction. And that fraction can be, here's one way to do it. We can say 100 minus source armor penetration divided by 100. Now, if we're doing it this way, we have to be aware of how the mathematics works. What we're doing is we're taking 100 and subtracting source armor penetration. So that right there tells you that if source armor penetration is 100, then this right here in the parentheses will be 0. It'll be 100 minus 100. And 0 divided by 100 is still 0, which means target armor will be equal to itself times 0. So source armor penetration of 100 is basically what we would call max armor penetration. In other words, it's the ultimate armor penetration, right? You got 100, you're ignoring 100% of your target's armor. For that reason, sometimes we scale this value, and we scale the value depending on the level of the characters involved, perhaps, or depending on any other criteria that the game designers choose. It depends on the game you play, and if you've played lots of RPGs, you've seen it done in a number of ways. Some games will say, let's take source armor penetration and we'll scale it by 0.25. 0.25F, for example. If the source character is 0 to level 60, and then if the character is level 61 to level 80, then this becomes an even smaller number. And then it takes more armor penetration to ignore a percentage of armor. And then you can scale it. You could even scale it using a curve table. It really depends on how you want to implement this. There's really no end to how you do it. But if we scale this by 0.25, then that means that we'd have to have 400 armor penetration in order to ignore 100% of the target's armor, right? And that means, well, one armor penetration point is worth 25% of what it was before. But scaling it here means, well, basically it takes 4 armor penetration points to ignore 1% of the target's armor. That's how it works. Now, if for some reason this value here is larger than 100, say we have 500 armor penetration, well, then we're taking 100 minus 125 because 500 times 0.25 is 125. And in that case, we have negative 25 divided by 100. That's a negative value. So really, if we wanted to, we could use this fmath max trick here on this value, or we could just make sure that source armor penetration is never going to be higher than some kind of threshold. And that's the way that I like to approach it. But either way, the point is that source armor penetration is going to reduce the armor. The effective armor will be some percentage less after this calculation. Now, after that, we need to reduce the damage that will be caused by the effective armor in some way. Now, if each point of the effective armor reduces the damage caused by 1%, then here's what that math would look like. We would say damage times equals, and then we could have parentheses and say 100 minus effective armor, all of that divided by 100. So if effective armor is 100, we ignore all of the damage. If effective armor is 50, we ignore 50% of the damage. If effective armor is 10, then we have 100 minus 10, which is 90 divided by 100. 90 divided by 100 is 0.9. Damage times 0.9 means we do 90% of the damage. So each point of effective armor ignores 1% of the damage. And of course, we can scale that. If we think that's too OP, if we think that's too overpowered, we can say effective armor times 0.3F. And then effective armor is going to ignore a third of the percent roughly. If this is 0.333, for example, that's a third. So it would take 3 points of effective armor to ignore 1% of the damage. That's how that would work. And again, you can data drive this any way you like. I leave that to you as an optional exercise. For now, we know that at least our armor and our armor penetration are doing something to the damage. Okay, so now that we're capturing those attributes and making this calculation, we can play test and see just how much damage we'll be doing now that armor and armor penetration is taken into account. Okay, let's go ahead and open up those assets. We have a secondary attributes test if we'd like to test some values. But I'm going to go ahead and just launch. And look at that, we got 15. Now we're truncating these damage values down to integers. So, of course, that's going to affect things. But we can set the secondary attributes to whatever we like. Now, just to prove that armor is working, we can change armor from attribute-based to scalable float and set it to some higher value, like, I don't know, 45. And we can see if we're doing less damage because, well, our enemies have a higher armor. And we're not because we're not actually using this test attribute, are we? We have to go into the data asset, go to secondary attributes, and change this to secondary attribute test. I changed that back to the normal one. Now we're using the test one, and now we're doing less damage. We're doing 7 damage. So this is a nice way to play with the values and see how much damage we do. Let's change armor to 90, see how much damage we do now. We do 6 because we're ignoring even more of that damage. And if I set this to 50, we should see that we're ignoring even more of the damage. Yeah, we're doing 1 damage now. So this gives us a bit of a way to tweak those values and see, you know, this isn't the best way to test this out, but it's one way. You know, ideally, we could have some kind of automated test that we write that tests a whole bunch of values and spits out some data for us. We could always do that. But for now, it's enough to know that increasing the armor on the enemy is resulting in less damage. That much is clear, and I'm happy about that. So at this point, we're taking block chance, armor, and armor penetration into account. And this comment here can go right down here where we're actually ignoring a percentage of the target's armor. And we can even add another comment that says armor ignores a percentage of incoming damage. All right, so our execution calculation is that much more complete, but we still have more to go, and we'll continue in the next video. I'll see you soon.